It'll all be in one video. So I wanted to go back over just to the island for a second. So it used to be, the islands changed as far as the code is going. It used to be that you didn't have to put a receptacle. So first of all, what's an island? Make sure everybody knows what an island is. In the middle of a kitchen will sit something like this, freestanding, nothing else attached to it. So this is called an island. Different from a peninsula, you don't sound out the R. And I'm from Florida, so we are a peninsula. So I just always heard this word as a kid. So I know no R. So if you haven't seen that before, it's not peninsular, just peninsula. That's different. That one's the one that's still attached to a countertop, but it sticks out a little bit, right? Sometimes as a bar, you might have bar stools, etc. around it. Both of those are kitchen related. So you have to have an outlet there. Well, I shouldn't say. You didn't have to have an outlet, right? So back in the day, you did not have to have an outlet. And today, you don't have to have an outlet either. But there is a change. There is a difference now. And I don't know if anyone's worked in electrical construction. Sometimes I have a few of you that's done a little bit of work, especially residential. Last module, I had a student that just also informed me of the information because I don't know a lot of times what's on site being changed every year as far as the codes go, especially in residential. That's way out of my world of actively working in. That's much more industrial towards the last years. So what has changed, and I just want to point it out, if you want to highlight it, it'd be fine to highlight it. I don't think it's that necessary, but it could come up as a question, which is, like I said, you still don't have to have a receptacle here, all right? That's why the article actually starts off with receptacle outlets if installed, all right, to serve the island or peninsula countertop or work surface shall be installed in accordance with one of these down here. These really have nothing to do with us as far as, you know, there's nothing we have to do here. Because, why? Well, 20 inches above the countertop workspace is not going to be something that an island will have. All right, the island's going to sit on the ground, and it's going to be flat. It's not going to have a backsplash, you know, of whatever. And that's what they want. They want on the backsplash of a countertop that you don't put this receptacle so high up that now my blender, the cord, again, I have the cord problem. These are short cords. So 20 inches is all you get as far as height from the countertop or any work surface, right? 20 inches max is what you get to be able to put the receptacle. But this is not an island issue. So we can remove one from having to concern ourselves with the island. And also, I would say, not a peninsula issue as well, because that's the whole point of the peninsula, is that there's nothing around it. There's no wall here, here, or here. So again, no backsplash, no 20 inches to worry about. They're not talking about below. It's on or above. It's either you're putting the receptacle on it, which no one's going to do, or above the work surface. All right. So number 2, a countertop using receptacle outlets assembled. So if you buy an island that's assembled, it just has to be listed for the work. So again, there's nothing really here that we can do with that other than make sure that it is listed. Usually these days, all of that is listed. And in a work surface using receptacle assemblies, again, it's all about the receptacle coming with the island, which is usually not the case. So the only thing to point out on the island and peninsula is the last sentence in the article. And this is what's changed. What's changed is you have to provide. I think I mentioned this yesterday, but I didn't specifically point it out in the article, and we didn't highlight it just to, where's that note coming from? Here it is. As it says here, starting there. If a receptacle outlet is not provided, so if we decide not to put the actual receptacle to serve an island or peninsula countertop or work surface, provisions shall be provided. And this is the part that's changed. We have to provide provisions at the island for future addition of a receptacle outlet to serve the island or surface. So this is why for these days in a peninsula or island, and confirmation from a student that I mentioned last module who said, yeah, we just did that. You gotta, and I mentioned this yesterday, you gotta put a junction box, you gotta run a Romex to wherever. The Romex can just run to another outlet, and then just be part of this circuit connection. All good there. Doesn't have to go all the way back, doesn't have to be isolated on its own breaker or anything like that. And then you would just leave your hot and your neutral and the ground wire sticking out in there, you know, coiled up, blanked off with a blank cover, so that future, that's what it's for. So for that point, I always laugh at this, because who would go as far as to run a Romex, put a junction box, run the wires, and simply not put a receptacle with a cover on it? I mean, you've not put in $5 extra worth of work into this. It doesn't seem like anything that we would do these days. So it almost is the code, right? This is almost the code forcing the receptacle to just be there. Although, like I said, a student math module said they did it like that. They just left it in there. I said, you didn't put a receptacle? They're like, no. And I was like, interesting. I've always argued that this code just forces you to add a receptacle, because why not? Apparently, because they don't want to. So there it is. So even if you don't want to put a receptacle, you have to provide provisions for a future receptacle. Two things, and we'll learn about this one next week when we get into Article 220. Two things in residential are now forced like this, where you have to provide something for future work. We did not usually ever, I don't remember ever as an apprentice or working as a journeyman in residential, remember leaving things for future work. All right, and now this plus the EV or electric vehicle systems, we have to now provide that as well. And even if you don't hook one up, right, you don't have to put the Tesla charger, you don't have to put any charger. You have to provide the circuit in the panel, you have to run to the junction box, and you have to leave the wires there. There is a minimum, we'll talk about that, because there is a minimum that we have to set up, but we'll get to that next week. All right, if anybody's got a follow-up there, any lingering island or peninsula questions. But that was it. That's the last little bit I wanted to cover there out of that section. And now what I wanted to catch out of page 88. It's not too complicated. I absolutely 100% know that if you had these questions in the Mike Holt book, that you had to go find the answers to them. Like, for example, at least one receptacle outlet shall be installed in a bathroom within blank of the outside edge of a sink, right? A nice little Mike Holt question. 100% know that you guys would go find the 3 feet, right? Maybe it'll take you a little bit to go find the 3 feet, but that's what we'll do here now. Just make sure we highlight all these little micro positional or locational things, so that if a question gets thrown at you, you're not wasting too much time trying to figure out where is this bathroom information at, right? It's just a random bathroom question about a receptacle. But here back into this section, article, or part 3 of this article, started all the way back at 210.52. We're down into the D's, and through, we'll just cover all these last ones.
Yes, sir.
Yes.
Mr. B?
Yes, go for it.
I think in Code A and the final, there was a question about the a bathtub, and then he asked for the same question but for a bathtub. So what would be the answer?
So receptacle within a bathtub?
Yeah.
Location to a bath, and it was like, was it for the GFCI?
Yeah, it was a receptacle. You guys remember? I don't.
Yeah, if I'm not mistaken, well, I didn't see the question. I'll say that. So I'm not going to do a. If I'm not mistaken, I remember it saying that. But there's only one section out of the code book. Well, there's probably other things, but I know as far as location to receptacles, there's one, and it comes out of GFCIs, and it's within. So we caught it way back. It's on page 80. It's on dwelling unit side of things on the Article 210.8 GFCIs. And then it's a question on, coming back up here, bathtubs or shower stalls where receptacle are installed within the area of 6 feet of the edge of a bathroom or bathtub. Then you have to have a GFCI. All right, so actually, let's look at this question, or let's look at this article, and then we'll use it to also frame it around the the bathroom location for the receptacle. So I'm assuming this was the question, and within 6 feet was the answer. I'm guessing, because
So that means within 6 feet we have to put a receptacle from that bathtub?
There's the question. That's the point. You don't have to. So if you go back over to this, it says where receptacles are installed within. So it's almost like if you put a receptacle within 6 feet of a shower. But let's lay out a bathroom, right? So the article that we were just looking at said, and we'll go back over to it. If you guys are still there, you can read it. It says you have to have one outlet in the bathroom. That's all it says. You have to have a bathroom outlet. So let's lay out a bathroom. Bathrooms, first of all, in homes are not too gigantic as far as the bathroom goes. So you might have a shower over here and whatever. Let's put the sink over here. And so generally, the receptacle is going to go near the sink, right? In fact, it has to be within 3 feet of the sink. That's where we have to put it if we go back over to that article. Again, this is not to deal with the question from code A. You would have to approach Mr. Aaron about it just to see what he was thinking, how he framed the question, and what the correct answer, if there was a change to it, was. Maybe you can point out an article as we go over this now that you can follow up with him if you wanted to do that. But if we're in a bathroom, first of all, and by the way, I wanted to highlight this anyway, one receptacle outlet shall be installed in the bathroom within 3 feet of the outside edge of the sink. All right, within 3 feet of the outside edge of the sink. So, in bathrooms, the receptacle has to be GFCI, right? Or not really, right? People think in a bathroom the receptacle has to be GFCI. No. The GFCI one said that if you were within 6 feet of the sink or the shower, then it has to be GFCI. So I'm a rich person and I got a gigantic bathroom, right? And my shower is only over here and my sink is only over here. And all this other area is changing room and dressing rooms. I have seen massive bathrooms like this. If there's a receptacle way over here, still in the bathroom, but way far away from the sink, and that just can be a regular receptacle. AFCI probably, if it falls under, I didn't memorize that one. I don't think bathroom comes into the AFCI. And then again, if it's behind things, accessible, all of that plays a role. But generally, bathrooms are smaller. And so the receptacle finds itself near sinks, within 6 feet of a sink, first of all, it's got to be within 3 feet of it. All right, it's got to be within 3 feet of it of any direction. It does allow you, by the way, if you read the rest of the article, it says the receptacle outlet shall be located on the wall or partition that is adjacent next to the sink. So it doesn't specifically have to be here, because sometimes there might be like a giant mirror here where you can't actually cut it into the mirror, but it's really a pain to do that. So the person might want to put it here, as long as it's within 3 feet. Now it has to be GFCI. Same thing if I put it over here, it has to be GFCI. Now it's sink and bathtub. But if I put a receptacle over here in the bathroom, because I have room for this, then it's a question of within 6 feet of and within 6 feet of. It could potentially not have to be GFCI. Now, most bathrooms that I've been in regular 2-bedroom, 1-bath, or 3-bedroom, 2-bath homes, have one receptacle near the sink, and that's it. Rarely, and you guys can think about now your bathrooms, it might be one receptacle. Usually there should be one to service, shavers and hair dryers and etc., but not two, where the receptacle now finds its way to have to be, is it within a sink or something like that? Or now, where that one actually plays out more is not so much in residential, but like in a gym shower area. All right. In dwelling units, more so it would be like a dormitory shower area or something like that. So Yeah, here's where a bunch of little code areas, articles can piece together the information you need versus it just being straightforward out of one. So I'm guessing his question was framed around within the 6 feet of the shower. So again, if I put a receptacle here and we are, 4 feet from the shower, then absolutely GFCI. If I put it over here and we're, 7 feet away, measured. But, bathrooms aren't usually 7 by 7 even. They're, usually like 5 by 7, or they're narrow enough. All right, hopefully that, helped you fill in some of the information. Again, if you need to talk to Aaron about it, certainly reach out. And the other thing I want to point out here is below, which mine and my bathroom actually violates this. I don't know if this was just a newer code. My house was built around the 70s, so I don't know, but mine's is well below my sink. But what they want is the sink, and if you decide to put an outlet below the sink, because again, you might have a mirror here that you're dealing with and don't want to cut into the mirror, then you can certainly put it below, but now within 12 inches of wherever the sink sits. I think they're specific about that. Below the top of the sink. Yeah, 12 inches below the top of the sink. So, because the sink has a basin part like this, sits like that, so not measured from the bottom of the sink, from the countertop specifically. All right, so that's one to grab. Outside outlets is going to be the next one, and I'm only going to be focusing on 1 family, 2 family dwellings. I think the multifamily dwelling is the same, except the question is just going to be coming out of single family homes. And for the most part in this module, while I'll sprinkle in, apartments and things like that and commercial buildings, we're going to be focused heavily on single family homes in that understanding. So for a house or a duplex, that's what these are. It says, and this is one of those, again, where it reads one way and it kind of means another thing. It says, or if you only read the first half, you'll get it wrong. It says, for a 1-family dwelling in each unit of a 2-family dwelling, so a duplex, that is at grade level. Now, this is a construction term. Grade level is the ground, right? Wherever the ground is in your house, that's the ground. That's grade level. So they're saying at grade level, meaning your house sits on top of the ground. Your house, or we're not talking about anything that's grade level. All right, so some kind of basement or submerged, whatever it is that you're building, some sort of fallout shelter, because it's underground, right? Because and you'll understand what they're trying to do here. They want a house that if you're in the front of the house, or I should say, if you're here, then the outlets should be available, right? If you're submerged and there's, you're going to have outlets inside now. You don't have an outside of your house anymore. That's why they're not talking about submerged stuff or stuff that's underground. So that's why they point out grade level. Again, these are little things that mean something. It can be something ignored just because not giving it too much concern, but that's what it means. It's because we're talking about outlets that are accessible from a yard in a house. So if you're below, then it's not accessible. So it says at least 1 receptacle outlet readily accessible from grade and not more than 6 feet above grade level shall be installed. And you got to catch this part, in the front of and the back of the house. And what does that actually mean? It means 2 receptacles. So it says 1 receptacle installed, but at the front and at the back of the house. So 2 receptacles. All right, so the codebook hates extension cords. That's what they hate. They don't want you doing anything over here and have to run an extension cord to reach that one. Voltage drop being one of their concerns, and extension cords being left plugged in and ignored being another one. They're usually very small conductors in there. You start loading up too much amperage and can cause fires. The other thing they want, that this receptacle is not too high. You have 6.5 feet. I believe that's to the center of the receptacle. It doesn't specifically say, but that's usually how it goes for things like that. Right? It does not say readily accessible from and not more than 6 feet. I would say it's to the center of the receptacle, but now that, as I said, it's the same thing for multifamily homes, except sometimes with apartment buildings you have different exterior entrances and exits, and so let's not complicate it too much. As long as you understand one receptacle in the front of the house, one receptacle in the back of the house. If you have a balcony or a deck or some kind of porch or anything else like that, one receptacle needs to be on the porch or on the balcony or on the deck, but the deck needs to be attached to the building or within 4 inches of the building, which is usually how these things are, right? They're, first of all, a balcony is attached. That would be scary to have a detached balcony. Same thing with the porch of the house should be, but sometimes a deck could be a little bit separated, I would say. Some people, like in my area here, you have to, if you want to build a deck, you have to get a permit. But if you build a platform, which is almost the same, then you don't have to build it. Then you don't have to get a permit. You can just build a platform on the ground, but you have to have it separated from the house. And then there's same thing. There is an inches away from the house that they want. If it's attached to the house, if you're literally putting your platform attached to your house, this is a deck by definition of their building codes. If I separate it, I can build it all the same way, but if I put a little separation from that, this is now a platform and I don't need a permit to build it. So this is why this rule is there. All right, that's why the rule is there. All right, well, you would think, why is this little 4 inches there? It's because you can build a platform instead of a quote-unquote deck. And then now also no receptacle outlet required if I build a platform versus a deck. All right, but that's getting into a little bit of the construction side of things. We don't have to complicate it too much, our understanding of this. Again, if you want to highlight one receptacle outlet in 6 feet above, shows up there as well. All right, but I did want to point that out just as far as what these things are and how we would approach it. All right, same thing for garage. Garage has a different height of 5.5 feet above at least one receptacle outlet. But here's the difference. This is not, don't put it this high. This shall be installed in vehicle bay at not more than 5.5 feet above the floor. So this one's not, it's not saying grade, it's just saying the garage floor. All right, so I have to have one outlet installed. But here's the kicker with the garage, and I do want to highlight this because I've seen people get this wrong in, I think, exam 1 or the final. It does show up as a question. Each vehicle bay, all right, each vehicle bay. And so sometimes in apartment buildings, I remember when I lived in Culver City, we had a fourplex, 2 on the bottom, 2 on the top, and there was 2 different garages, but we had 2 bays, meaning for 2 cars. And so each bay needs to get a receptacle, right? Again, extension cords from one to the other, they do not want. So if I happen to have a 2-car garage, 2 receptacles. 4-car garage, 4 receptacles. Receptacles, this is not circuit, this is receptacle. It would probably be 1 breaker feeding that receptacle, that receptacle. If we had more garages, remember my rule of 6? That's how we would approach it. All right, accessory buildings, if they have electrical power, sometimes like a shed does not have electrical power, so you don't have to put an outlet. You're not forced to put an outlet on a shed. If it has electrical power, then yes. Same thing with a, by the way, all of this is the same up top, right? It's at least, these are all the same. Basements, garages, sorry, it's not shown on yours. There we go. Basements, garages, and accessory building all have to have one receptacle within 5.5 feet of the floor, and the following should also have one receptacle within 5.5 feet of the floor. The accessory building, the basement, if it is an unfinished basement, which is just means that you didn't put drywall in there, it's not like a family room or anything like that. If the basement was a family room, then it would be treated like a family room, where we'd have to put a receptacle, and then 12 feet, we'd have to put another receptacle, and 12 feet, another receptacle. What they're talking about is one of those unfinished basements where you still have like The concrete pillars are still there. Maybe sometimes people put a washing machine or dryer down there. It's about it. But, you know, the walls are concrete, unfinished, no drywall, no anything else like that. In other words, this is not a livable space. That's what they mean by unfinished portion of the basement. Now,
so does that mean that we need an outlet? Or no,
you need to, yeah, you need to provide one receptacle down there. You do need to provide, say, you know, this is the basement of the house. I need to put at least one receptacle. I can put more, but just one has to be down there. For whatever you want to do down there. Again, no extension cords going up to the regular house. Now, if you put the, you know, stud the walls, put the drywall, put some sheetrock on top, now you start laying this out, now you got some lights in here and etc. This is now a livable space, and it gets treated like a family room, living room, where next receptacle 12 feet, next receptacle 12 feet, and we lay out the room standard like every other room in the house. But an unfinished portion of the basement gets treated like a garage. It's just a storage garage area. One outlet is all you have to provide for it. Again, you can put more outlets if you'd like to. You know, sometimes people want more outlets in their garage. Not a lot of use for an unfinished basement having more than one outlet, but. Now again, you could also say, I want to put my washing machine down here and I want to put my dryer down here, and then I can run electrical power to both of these from my panel. I can put as much as I want down here, but I'm not required to put anything except one outlet. Same thing for the accessory building, or again, a shed. If the shed, you're bringing power to it. If you don't, then you're not forced to put an outlet. Hallways, one outlet if. All right, here's another micro length of distance that you can get a question wrong because you didn't know where to find this. It's not so much as getting this wrong because I didn't know it. It's I couldn't find it. It's just this one little tiny sentence that has some information. If you can highlight it now, then as you're walking through a page, you can just stare at the things that are highlighted and see if your answers are there. One outlet if the hallway is 10 feet or more in length. Hallways are usually not that big, but if a big house has long hallways. Let's see here. And the foyer. The foyer is the only one I want to point out because I actually lost an argument online, if you could believe it. It's arguing with another electrician. I don't know, the things that you find yourself arguing online with another person. So, foyer. What's a foyer? House, overview of the house. We're looking at the house from the top now. And the foyer would be something that is like this. Sticks out. My front door is here. And this is the area where you greet people and, you know, hang your hat, take off your coat, and all that good stuff. So they're small, right? Foyers don't tend to be a 20 by 20 area. Unless you have a big mansion, then yes, but small. So there is some measurements here with the foyer. So let's read that first. Foyers are not part of a hallway. All right, so they're not a hallway. And have an area that is greater than 60 square feet. Shall have a receptacle. So there's the first thing about a foyer. Is the foyer's got to be 60 by 60, which is 8 by 8 is 64 square feet, so just shy of, so 7 by 8 or 7.5 by 7.5 or something like that. 60 square feet. Then you got to put an outlet. So if your foyer is 8 by 8, you have to put an outlet. 64. 9 by 9, 10 by 10, outlet, outlet, outlet. Now, this is where I lost the argument. Because if you go one page back to page 87, the code book defines a wall as 2 feet or more. But in a foyer, the wall, and this is what I lost, is defined as 3 feet or more. So I could have gotten that question wrong, thinking I was right on a journeyman exam, going, you know, in a foyer, something laid out like this as far as code question goes, shall have a receptacle located in each wall space, blank or more in width. And of course, I have 2 feet or more in width just as my standard for wall spaces. So it just changes. I want to point that out. You guys can highlight that if you like, 3 feet of wall space, or the foyer. In a foyer, a wall space is defined as 3 feet. There.
Mr. P,
Yes.
could you please re-explain that wall thing? It's really blurry for me, that wall.
Sure. Let's use the.
You can do that last if you want.
Yeah. Let's use the diagram here because we have a little tiny wall, right? So if you walk into this bedroom, or whatever it is, bedroom, we'll say. So I got a little closet right here. So this wall space is 2 feet or more. It's not giving us the dimensions, but it's saying 2 feet or more. So let's just say, let's give it some dimensions. Let's say this is 4 feet from here to here. All right, so this wall space is now, so I have to put an outlet on this wall. Now, if this wall sticked out just a little bit, let's say, like a little partition, that was only, let's say, 18 by 18, a little 18-foot wall section, then no, I do not have to put a receptacle on either side of that. All right, by the way, you only have to have it on one side. In other words, I am not forced to put one inside the closet. So it's just what they defined as a quote-unquote wall, right? This is not defined as a wall by the code book. It's a thing that sticks out. It has drywall. It is a partition or something. It's not a wall. In the foyer, that just changes to 3 feet. Go ahead.
Talking about the width of the wall or the height of the wall?
Well, height it wouldn't be, right? We're talking about length and directional side to side. So the height, I mean, you can be standing in a room with 10-foot high ceilings or 20-foot high ceilings. So we're not going up with receptacles. We're going right lengthwise across the wall. Right? Does that make sense?
Yes.
All right, good to go. Yeah, so let's see if we can, and the countertop is different. Countertop is defined as 12 inches of countertop space. Where you run into that is if you have a little bit of countertop space, then a sink, then there could be a question of, let's say, for example, I have some countertop space here, but now the sink is here, where let's draw that a little bit better. Let's go, here's my countertop space, full length of it, right? Here's my sink. And now this gets divided into 2 sections because no receptacle will be here. All right, that's what they're pointing out on the top of page 88. Top left side, that's what they're pointing out for us. Sink, or this could be the range, the oven, things like that will break. So now I have 2 sections of countertop. All right, this is section 1, this is section 2. The question is, do I have to have a receptacle here or not? And that all depends on how wide, now width in both cases, how wide this countertop space is. This countertop space is 12 inches or longer, then you have to have a receptacle there. If it happens to be very small, sometimes that happens where this just is a little bit of countertop space. It's annoying because you don't get a lot of countertop space, but now no outlet required here. Because they don't think that this is enough space for you to put your microwave or sit a blender there or something like that. That is going to require the outlet. But 12 inches or more, now you can put your coffee maker or your air fryer or something could live there now. So that's what they're judging it as. It's always, okay, I know to do it, but also why am I doing this? And again, this is all about extension cord. So this is the other difference that we wanted to point out there. So now when we jump over to the foyer, then the same thing. It's just the foyer changes to 3 feet versus 4 feet. Versus 2 feet, I meant to say. All right, everything else down the rest of this article gets into different locations that we don't have to worry about to continue understanding them, as far as meeting rooms and things like that, additional locations. So we can comfortably wrap up this article. And that'll be everything that you'll deal with in the exam. So let's drop down over to page 90 where we have feeders. All right. Article 215. All right, it's the next article, 210, then 215, and then next week we do 220. So, and then next module you guys do 230, 240, 250. Right, structured in that order. And the codebook built it that way. These all kind of follow each other. After the 100 articles, once you get into 210, they follow each other. So this article is on feeders. So first of all, let me point out what feeders are. Okay, we're actually going to talk about feeders again when we get over to week 5 and we talk about outside branch circuits and feeders. So let me go over to that article or that lecture, only because I have a bunch of pictures here to show. All right, there's some show and tell stuff which we'll get to. So this is what we call a service that you're looking at here. This is a service. And this is what we call a service drop. Right there, that's a service drop. Technically, that's not the service drop, I should say. The service drop is the one that's coming from the utility company that will splice to the ones that are here, right? To the wires that we provide. Those wires that I'm pointing at, I meant to write, those are feeders. Right? Those are feeder conductors or feeders. And this is all we provide for the electrical company. We do not have to tie into the transformer. They come in and they do all that stuff. So those feeder conductors are just from here to that meter, and then over to, I'm guessing this panel is inside the house, over to the panel. All right, so in other words, they're the wires, those wires that you see right there curled up, and that's as much as you try to leave for the electrical company, so they have some, you know, ability to move things around, etc. They are not very long distance. They're very short, usually. Feeder conductors are very short, especially for residential. But this is all this article is about. Those wires and the main breakers that go with these wires. Right, the overcurrent protection devices. So wires and breakers. Now we just did wires and breakers when we did Article 210. All right, I'll just point out where we did that, unless anybody needs this image, and we'll come back to it. We'll talk about service and we'll talk about these service drops. If anyone has any questions here from any of that you're looking at, certainly answer it. But this is a setup where there's a few ways that you can set this up. Sometimes the meter and the panel are together, where you have your breakers and the meter. It's called the meter panel combo. Great name for it. Sometimes you have this separate where the people don't want to, maybe it's cold, maybe it's wintry there a little bit too much, you got a lot of snow. Going outside is not fun throughout the year, so if you have to go reset a breaker, it's not fun to go outside in, you know, -20. So it's better to have the panel inside the house where I can deal with my breakers if I need to from temperate climate, not outside. So as I said, unless you have any question, I'm going to go back over to where we were. Back over to the article of where feeders were. So the only reason that is because we did wires and we did breakers, just to point out where we did them and where exactly did we do them. So I'm just looking at the overview here so that I can go, yeah, all right. So when we did our conductors, we said when you select a wire, first of all, the wire is going to be selected from Article 31016. These are all the wires that we picked them for. This goes for branch circuits, and this goes for feeders. So those wires that I just showed you that came down and fed the panel inside the house come from here. When you pick those wires based off of the same setup here. Continuous or non-continuous. Continuous gets increased. Non-continuous doesn't get increased. If you're looking right at page 90 from the feeders, it's the first note. Feeder supplies continuous loads or non-continuous loads or any combination of, etc., plus the 125% of the continuous. Literally the same as this note here, where branch circuits supply continuous and non. We've already selected wires, branch or feeders. We already know the system. So that's why I said we don't really have to do too much in this article. And we'll go over this tomorrow when we review, but I'll give you a couple of continuous or non-continuous loads in the exam, and you'll find wires for them, and you'll find breakers for them. Whether it's a non-continuous feeder load or non-continuous branch circuit load, doesn't matter, the approach is the same. All right, same thing for overcurrent protection. Article 210.20, overcurrent branch circuits, continuous and non-continuous, where, etc., 125. If you look at page 90 and you look at just to the side, 215, overcurrent protection device, and same all the way through, 125% of the continuous as well. The only thing really that this article is for actually a couple of the things around grounding and ground fault and the ungrounded conductors versus the neutrals. But you guys are going to pick that up when you do services with Mr. Williams in Code C. Because the only focus for this module for feeders was to understand how to select wires for feeders and how to select breakers for feeders. And as I said, we have the method here, which we'll practice again tomorrow. We're not experts yet, maybe, but we'll practice dealing with continuous and non-continuous selecting wires, and also dealing with continuous and non-continuous for selecting breakers. And also, the voltage drop question, actually I don't remember seeing it. Yeah. Actually, I meant to say, there is one other reason I jumped over it. And it's where the voltage drop question is. I apologize. This is the only real thing to come into Article 215 for. Sorry, going back up to where we were at. Article 215, page 90, top right-hand side, 2, just of the first article, where it says ampacity adjustment or correction factors. Now, this is another factor that hits conductors. All right, so let's just kind of recap when we select wires, right? When we select wires, as I was mentioning yesterday, when we were doing the voltage drop thing, this is the first approach. What are we energizing? Is it continuous or is it non-continuous? And I'll increase the amperage of the continuous ones. All right, so I go find my wire, whatever the wire is. Let's just say it's a number 8, or a bunch of number 8s going into this circuit, 2 hots and a neutral or whatever. The wire size is number 8. Then I said yesterday, well, if this thing is 500 feet away, now we gotta try to do a voltage drop calculation to make sure this number 8 is still good. This number 8 now is too small of a conductor because the voltage drop is too big. Then we may have to increase this wire size to the next size higher, which then becomes a number 6. All right, so what I mean to kind of wrap this up as is, once you've selected the wire based off of the amperage of what you're energizing, then you should run it through a voltage drop calculation if it's very far away. But if it's not far away, then the number 8 is the good wire, right? That's the size wire we want. However, there's 2 other factors that we could also run into with wires. All right, now we're going to catch this when we do Article 310, which is towards the end of next week. Thursday we start Article 310. We'll finish it Monday of week 4. But this is going to kick us over, and you'll notice the ampacity adjustment factor and correction factors kicks us over to Article 310, where just like voltage drop, needing to increase the size of the wire because this load is way too far away, so let me just pick that number 6. If your wires are dealing with excessive heat created by 2 things. 1, the sun. All right, they're outside, they're exposed, and they're on a rooftop of a building. They're just dealing with, they're in a conduit, so trapped inside a piece of metal. Heat from the amperage can't really get out. Plus I have 100 degrees on the rooftop of a building. Plus the roof of the building is gonna kick heat as well. It's gonna be a lot harder on the surface of the building. So if my conduit is laying on the roof of the building, then I have to deal with a different, all of that is covered in Article 310. So there's more to unpack with it, which is why I'm not covering it right now. But all of that heat could also cause the effect of the same thing. I might need to go to a larger size conductor because the wires are dealing with too much heat. And Gerald, who's not here, pointed out the other day, Heat is a big factor on conductors. Heat is the thing that amperage is. Amperage is heat. So you already have heat. The wires are already dealing with a normal heat from the amperage running through them. Now you put them in a conduit and that heat can't get out. Now we have more heat in the conduit. Now this conduit is on the rooftop of a building. It's the middle of summer. That's called ambient heat. That's one of the corrections that we have to deal with when we select a wire. Literally just too much heat in the area. The other one is when you put more than 3 current carrying conductors in a conduit. Right, meaning hot, hot, and a neutral, or a 12-3 or 12 or 14-3 or whatever, 10-3. If you decide to run more, which we're allowed to do, you can run as many wires as you want in a conduit, as long as you're picking the conduit size to match all the wires. You want to put 4, 5, 6, 7, 8 wires. Well, here's another heat-related problem. You're bringing in more wires with current, more wires with amperage. This is going to just generate more amperage and more heat inside the conduit. So that is another adjustment that we would have to make to the wires if they were ran with more than 3 current carrying conductors. But we'll pick this up. That was what I was just going to point out. That is a big factor that you deal with, especially with feeders. Because why? Because they're outside dealing with the sun. And as we'll learn when we get into Article 310, a lot of times with feeders that are for large amperage circuits, 500 amps, 1,000 amps, 2,000 amps, you run more wires in the conduits, so you're running into the problems of having more than 3 current carrying conductors in the conduit. Now, hopefully that all made sense. If it didn't make sense, you're sitting there going, I got some of that. Don't worry, we're going to come back to all of this adjustment and ampacity correction factors. All right, so for now and for exam 1, this is all you have to worry about when it comes to wire size selecting. Continuous or non-continuous, only increase the continuous one, whether they're feeders or branch circuits. Same approach when we're searching for the breaker. Just at the end of the day, we're going to 2 different articles, one for the wires and one for the breakers. All right, same approach for both. All right, as we said, this number 10, we get a 25 amp breaker. That's it. Now, again, you throw this number 10 in a conduit with, 12 more number 10s. Now, that number 10 might have to become a number 8 because there's too much heat inside that conduit. All right, hopefully you're getting that concept. All right. Second, we introduce more heat to the situation, then the wire cannot hold the amperage anymore that it used to be able to hold, the ampacity. That's why they call it an ampacity adjustment. All right, it says here the minimum size wire, feeder conductor size, shall have an ampacity of not less than the load it's going to serve, so continuous or non-continuous, after you've considered any correction factors that 310.14 gives us. And like I said, those are temperature related. Yet we're not going to go over to them right now. Not going to put them in this. Really, because of Memorial Day, we missed a day of being able to deal with a little bit more out of this article. So it's okay because we catch it in Article 310. All right, I don't think I have anything else for Article 215, if anybody has a follow-up. All of the grounding stuff you will catch next module as well. So let's wrap up. Let me see where I have this lecture. That's not it. Is that it? Yeah, all right. So let's wrap up today with MC cable. All right, let's jump over to this Article 220 and get into a cable system. We're going to have 2 systems of conduit or things that carry wires. One a cable, one a conduit. And I pointed this out, Antoine, you have it as well. The FMC, this is different from MC. Both sort of the same. FMC is flexible metallic conduit. And this one should be flexible metallic cable. I don't know why the F is not here. It just says MC. And it doesn't stand for metallic cable. It stands for metal clad. All right, metal clad right there in the first word. And hold on 1 second as I go over to the article. Do I have the page? I'm still lost. There. All right, 221. Okay. So MC cable. Now, let me actually point something out. I mean, you all have worked with it, and everyone has seen it now. So this is MC cable, and if you want this note, go ahead and grab this note. You do not need it per se. It's not going to come up as a question as to what's the difference between. But just so you know what the difference between is, anything that says cables like the Romex comes with wires. That's the difference between a cable and a conduit. All right, it's gonna be important that you understand this because of one article within this within Article 330 that specifically talks about this. All right, and since we're working with two different flexible conduits this module, but one is a cable system versus one being a conduit, there's going to be two different notes for it. All right, and I'll point them out now as we get into this article. Now, there's another one, right, which we do not work with. It's actually not that typical on the East Coast, on the West Coast. It is only a Northeast Coast. This is basically where the most where I've seen it. It doesn't specifically mean that you can only use it in the Northeast Coast. It's just that that's where it was originally made and that's where it's originally used. It's called AC cable. Armored, that's the first word here, is armored clad cable. The difference is it's not made out of armor, but it's made out of steel. So it is like armor. Versus MC cable made out of aluminum, which, as I showed my online students, you can just crack in half. And you can literally pop open MC cable and cut it with your side cutters. Not AC, not steel. This one you're going to have to hit it with the hacksaw. Your rotor splitter, yes, but you cut a couple of these and you have to change that wheel a lot. Visually, they look the same. I do have a picture of it here so you guys can tell the difference. Outer shell looks the same. But the steel one is a little bit more dull than the MC. Aluminum is very shiny versus. But the main thing is the ground. The AC cable, since it has steel on the outside, isn't really concerned with the insulation on the ground. Now, Romex isn't steel on the outside. Why isn't it worried about because it's going in residential. Versus MC cable. What's the difference between MC and Romex? MC is metal, aluminum, but it's a metal. And therefore, for in-person, you guys have this, the metal framing members, which is running Romex through metal framing members. While you're allowed to do it, you have to use bushings around every single hole, so nobody's doing that. And so MC cable or AC cable are the ones that you would use whenever you have metal studs. So again, AC cable is not going to have the ground inside versus MC, which will always bring the insulated ground because the outer shell is just a little bit weaker. All right, so they're worried about that. All right, so let's jump over to the article. There it is. Yep. So again, cable systems comes with wires. So let's jump into focuses. What do you focus on when it's a conduit, right? I covered this a little bit when I was reviewing with you guys for the final. If it's a conduit or an MC cable or a cable system, if it's something that's running the wires, doesn't matter whether it's Romex or EMT. The focus is always, where can I use it? Where can't I use it? How do I support this thing? And then is there anything unique about this particular one? Like PVC is plastic, so maybe there's something there. Galvanized is steel, so rust is a worry. This is aluminum, so this has its own thing to deal with. So uses permitted, lots of them. Right? MC cable has lots of uses permitted. In fact, not much limit. All right, not much of a limit. There are uses not permitted. There's only one conduit that doesn't have uses not permitted, meaning there is only one conduit that you can use anywhere conduits can be ran. That's RMC. It does not have a uses not permitted, but this one does have a uses not permitted. So going over to the code section here, the only things I want you to worry about here are the first 5. You can use it for service feeders and branch circuits. You can use it for power. They mean outlets. All right, when they say power, like power, what do I mean by power? Outlets. You can use it for lighting circuits. You can use it for control circuits. Signal circuits would be more along the lines of like not just traffic signaling, but in that sense as well. You can use it inside the house, outside the house, doesn't matter. You can use it behind the drywall, you can expose it. And number 5, direct buried. I want you to learn that term. Direct buried means I can put the MC cable directly in dirt. That's what direct buried, sometimes called direct burial. Like a burial, where, you know, where cemetery burial. But specifically, we're identified for such use. So not just all MC cables, there are MC cables specifically that will say for direct burial use. So that would be the only thing. It's not just any MC cable is for that reason. That's why I say you can use them everywhere, except there's like some, it's just you got to make sure you're buying the MC cable that's rated for that. Same thing with wet location, damp locations. Same thing for hazardous locations, which is not usually, like Romex you cannot use in hazardous locations. But it has to be. So if you look down here, if you have some direct burial information. There's a couple of follow-ups with this article as well. All right, but all of those extra ones as far as dry location, hazardous, aerial, don't worry about those too much. Just the first 5 to highlight. That's where you might get a question out of. And now for where can't I use it, I would say the first one is the number 1. That's the biggest focus with MC cable, is because it's aluminum, not like the armored one, then subjected to physical damage. So even though it can be exposed, meaning I can have it around the general public, I can't put it in such a way that it can be damaged, physically damaged. So if that means somebody can grab it, that's physical damage. If that means that a forklift can run something into it, that's physical damage. So we don't try to put them low, up and out of the way in the rafters, up on, you know, in the roof or something like that would be absolutely the best place to put it. And so the only thing you have to worry about is corrosion. That's the one. There is a corrosion protection that we can put on all conduits, but all right, that's why it says protected by a material that can resist it. Right? It says we're exposed to any destructive corrosive condition unless, oh, there is an unless. Yeah, if the MC cable that you're buying is actually for that use. All right, that's why I said number 1 is the only one to really focus on when it comes to uses not permitted. And guess what? There's only 2. That's it. There's only 2 things you can't use MC cable for. One is use it in such a way where the MC cable is not rated to be used for, because it has so many uses permitted. You just gotta make sure you're using the right one. And then the other one's just like, okay, it can be used anywhere except just get it up and out of the way so it doesn't get damaged. So it's like EMT. EMT almost follows the same thing. Anywhere.
So we can put those inside an EMT conduit?
Okay, so putting cables that have wires in a conduit, yes. And when we do the FMC article, we're going to actually cover this. There are 2 tables in the back of the code book, tables 4 and tables 5. You even can get ahead if you wanted to jump over there and look at a couple of things. They're all part of chapter 9, which you guys already looked at last module as far as the annex section. I know because I reviewed it. We're going to be looking at this again because when we select FMC, we're going to do some sizing. So a cable can go in a conduit. Yes, I can run Romex in EMT. I can run MC cable in EMT. I just have to use these tables back here to find the appropriate sized EMT. All right, so it might mean having to go up to a 1-inch EMT to be able to run MC cable inside of there. I don't know exactly what that is, but there is a percentage. No matter what size your cable is, it has to only take up 40% of the inside of the conduit, leaving 60% of area not filled in. So yes, you can run MC cable inside of EMT as long as you follow this. The MC cable does not take up more than 40% of the internal diameter of the conduit. To find out all of that, you need to go to these tables to find out the internal diameter of conduits and etc., which I'll walk you through, but if you wanted to get a head start. All right, and they give you the, if you're running Romex or if you're running MC cable, but, go get a piece of 1-inch and run MC. It should be way fine. Exposed work has a couple of things with it, just like with Romex exposed. Romex can be exposed, but there's concerns with it. It can be on the underside of things, and it says here, exposed runs shall also be permitted to be on the underside of joists, which are like studs, like wall. Like the wall is called a stud, the thing that holds the drywall. But if it was on the ceiling, this is called a joist. This is a stud, right? Just carpentry terms. And you have to get familiar because the code book does throw a few of these carpentry terms to us. So it's saying, can I run MC cable below the joist? So, as long as nobody can grab it, right? Keep in mind physical damage. Yes, you can absolutely do that as long as you support it, right? And it says right there, as long as no physical damage, last part. Make sure people can't reach that thing. Or, a forklift driving under it grabs it or gets snagged by something. So not much really here to point out as far as exposed work. So here's the one unique thing, right? I said, where can I use it? Where can I use it? How do I support it? And is there anything unique about this conduit? And yes, it comes in here. This is the unique thing about this conduit, which you won't find in any other cable or conduit article. All right, and it has to do with radius of bends. All right. Okay. So for this, we go back to what I said about just a second ago about MC versus FMC. One is a cable, one is a conduit. So what is the difference between a cable and a conduit? Well, there's wires, right? The wires are already in MC, meaning, what does that mean? It means I don't have to pull them. Why is that a worry? Well, when you have to pull wires through a conduit, here's the best wire pull you'll ever do. Short distance, doesn't matter. Straight. A straight pull. No bends. That'll be the easiest pull you ever make. Right? Obviously, leaving room in the conduit to be able to pull these wires. This conduit run gets a little harder if there's a 90. Not by a lot, but 190 already makes this wire pull a little more difficult than it was when it was straight. Harder wire pull is if I have 2 90s or 3 90s, and I'm allowed a maximum of 4 90s. Between, and again, I mentioned this a little bit when I was reviewing with you guys last module, only because I know these are coming up for us. That's the maximum I'm allowed to do. 360 degrees, which would be 4 90s. And then if you were running offsets, then you would have to calculate them in, remove a 90, add an offset, and add up your degrees. So this is only a concern when you're dealing with a conduit or tubing for EMT, when you have to pull the wires. Because as I said, the easiest pull will be a straight run. Put 190, it's a little bit harder. Put 490s, this is a little bit harder and harder and harder yet. So putting a 5th 90 here or a 690, that's a very difficult wire pull. So in all of the conduit articles, you'll find that 360 degree note, maximum allowed to run. In fact, when we get over to the FMC article in week 5, you guys will notice that rule again. I'll point it out when we get there. But you will notice that this one does not have it, right? Going back over to where we are, 33024. Does not say anything about 360 degrees. What they're worried about is bend radius. All right, they're worried about the bend radius. So for them, an MC cable, here's what you don't have to worry about. Here's my junction box. Here's another junction box. And I'm going to run some MC cable. I can run the MC cable like that. All right, this is way more than 360 degrees. But they don't care because you don't have to pull wires through this now. The wires are already there for us. So what's their worry? And I see it when you guys say, this is what I'm looking for when you guys send me pictures of your labs. What they're worried about is you making too tight of a bending radius on one of these, where you're making all your turns and one of them is way too tight. That's what they're worried about. Because MC cable is very flimsy and this potentially can happen. All right, maybe you're trying to get it into the junction box. As I see sometimes, you got a metal stud here. You're trying to get the MC cable here. This is okay. This is all okay, but again, we could really make some narrow. This can start to get a little bit too narrow. And not so much that it's the distance between here and here that they're worried about. That's the radius. This circular radius right here. That's why they're calling it a radius. Technically, from the center to the outside is the radius, but. So the way to understand it is, by looking at it, first of all, since you already have the wires in it and you're just going to install it through metal studs and all that stuff, do it in a way that you will not damage it. All right, bends and MC cables shall be so made that they don't damage it. How do you damage it? Well, the radius of the inner edges of any bends shall not be less than the required amount down here. Now, there's a few here. Smooth sheath, we're not using that one. Shielded conductors, we're not using that one. We're using this one. Corrugated or interlock type. All right, if you think about your MC cable and the way that little metal, it's interlocked. All right, so we're using that one. So what they want is 7 times the internal diameter of the inside. So here's my MC cable that I ran. I'll do it in 2 dimension. All right, here's the little MC cable. So it's the inner and the inner and here and here. That is not allowed to be less than 7 times the external diameter of the metal sheath that we're using. Now, for the most part, as far as MC goes, while you can get some bigger ones, all right, while you can get actual 1/2 inch MC cable for, like, I think the number 10s come in that one. I don't think it goes up to 1 inch, but maybe it goes up to 1 inch. 3/4 for sure. I don't remember it goes up to 1 inch, but maybe it does. Actually, it goes up, yeah, it goes up to like 1.5 inches. You can get some larger ones. And I only am just now realizing because I think, but ours is 3/8. That's the one that is almost standard for all MC use that I've ever worked with. It's all been either 14 or 12 gauge, mostly 12 gauge, if not always 12 gauge, and 3/8. So if you wanted to turn that into a decimal for easy multiplying, it's 38. It's actually 0.375 if you wanted to turn 3/8 into a decimal. Just that's the easy way that I like to multiply this. And you can do 38 or 37.5, it doesn't matter. So I'm going to multiply that just so you guys can have a finished product here. 7 times 0.375, let's say. And this is going to be 2.625, which is approximately 2 5/8. You're not going to have to do this math for me. All right, not for this exam, I don't think. I think it might come up in the final, but it is going to come up. And you don't have to do this for ours, but if they asked you on smooth sheath MC cable, and it depends on the diameter of the actual conduit. All right, so there's some different ones there, and shielded conductors 12 times. Again, the one we're working with is 7 times. And
So
I would
that
say 99.9% of the MC that's out there. Go ahead.
2.258 is that distance
Yes,
between the
exactly.
bend.
2 and 5/8 between here and here. That would be the minimum that you can, when you fold your MC cable like this, that would be the minimum that you can bring them both together, which is very small. I mean, if we're actually looking at distance-wise, 2 and 5/8 is very tiny. So you can really run your MC cable, that 3/8 one, fairly tight, but that would be the smallest we can do. 2.5 if you wanted to bring that closer to a number that is easier to, something like that. There's their worry with MC cable. Their worry with MC cable is that these radiuses, because if you start bringing this any tighter, remember how I showed you to break the MC cable? You can break it. If you bring this radius any tighter, it can pop, snap the interlocked metal, and now you're exposing the wires. Now here's the weird thing is FMC, the annoying thing, not weird. FMC, the flexible metallic conduit, it's also flexible, but you can't do this with it. I can't just lay it out like that on the floor and let it be all curled up, because since it's a conduit, it is viewed as you will have to run wires through this later. But we'll talk more about that conduit when we get to it, because generally with these flexible ones, we run our wires before we install it, so we treat it like an MC cable. So we're never actually pulling through flexible like that. All right, now last but not least, and we'll wrap up here. I'll let you guys go right after this one. Not too much else to say about MC cable other than how do we secure it and support it. This is universal for all flexible conduits. Doesn't matter which one it is. FMC, LFMC, the liquid tight one, Romex, any of the flexible conduits will all be within 12 inches of every box, cabinet, fitting, or etc. All of them. This is universal for every one of them. What changes is after, right? The support. Support for this one is 6 feet. Whereas FMC, if I'm not mistaken, is 4.5. Romex is 3. So it changes in the after. So remember, leaving a box, 12 inches within that, and then from that support, at intervals not exceeding 6 feet. You can highlight that 6 feet twice. You can highlight it here, and you can highlight it there if you wanted. And last but not least, I do want to point out that unsupported cables, because these flexible ones are in many cases used at very short distances, if this MC cable is not, more than 6 feet long, then you don't have to support it, or you don't have to support 6 feet of it after the last support. All right, now what do I mean by that? I mean like this. All right, let's say we're running a longer piece of MC cable, and then eventually I want to drop down and catch this light fixture down here, right? I got a light fixture there. So if I put a support here on the ceiling, let's say this is the ceiling, and I support the MC cable, now I can let this drop for about 6 feet without having to support it again. Right? That's what that note is saying there. Unsupported cables. Number 2 is not more than 6 feet in length from the last point the cable was supported to the point of connection at the light or other electrical equipment. But what also that boils down to is, for example, let's say, same situation, I have a ceiling here, and I have a junction box, and let's say I ran conduit from here to here. Right? I ran a conduit from there to there. And now I have a light fixture or a machine that we're going to drop down to down here, or a light or whatever it is. Same thing. As long as this is not more than 6 feet, then you don't have to support it. All right, you don't even have to put a first one there. All right, so these can flex out at 6 feet in length. And that's the only one I wanted to point out of the unsupported one. The first one is just on areas of the building where you can't access things. So we don't have to worry about that one. All right, I'm going to pause the video there.